Okay, so welcome all to the November webinar, the AI ecosystem, building a technical and business perspective. It's me, Karim Rabie, and I'm really happy to welcome today my colleague and my friend, Mohamed Hamada, who is going to co-present the webinar with me.
Thanks, Karim.
Hamada,
Happy to
thanks.
be with you all.
Great. So just quickly, let me remind you about the objective of the webinar or the abstract. So the idea of this webinar is to help I would say the professional community. I mean, people working on the technology domain to understand the entry points to the AI, because AI landscape, as we all know, it's vast, and we are trying to simplify that by having some sort of a structured way of interpret the different layers. And also, we will be happy to share our experience being I mean, working on AI, Hamada on Cisco and me on Red Hat. So I hope we can cover that in 1 hour. Okay. Okay. So the starting point, and I searched for like a solid example that we all know, especially I would say my generation. And we see like the evolving or the evolution story or the rise of NVIDIA. So it all started, as you'll see, in the late 19s, where my generation, we used to be like very excited when we buy the NVIDIA graphics card, because this means that we are going to play our favorite game, which is, Quake and many other games that we all played, at least people born in the 80s. And then suddenly, we witnessed the rise of NVIDIA, and as you all know, this kind of these spike that happened with NVIDIA stocks. So,
Yeah.
Hamada, how do you see that?
Well, I can only say one thing. If you have invested $100 in 2020 in Nvidia, it's 8,000 US dollars today. So we are a bit late, and well, we don't know if it's going to increase or the bubble will come. So this is something we will see in the future. But yeah, generally, yeah, I mean, the guys in Nvidia were seeing the future. I mean, if you follow GTC with Jensen Huang and what he was saying, so they were seeing this happening a long time ago.
Yeah, actually, we will talk about that. And speaking about the innovations, they saw that coming really early. So in 2012, they announced the company to be an AI company, and they even made this CUDA, okay, the software platform that allows the developers to program the NVIDIA, not only for the GPU, not only for the graphic part, but for general purpose stuff. And I think this has put them ahead of the others. So I hope in the webinar we are going to tell the same story, but with different themes, just to understand the rise and the momentum of DI. And since we are trying to help the community to get a technical perspective and business perspective, so we need to understand how to interpret, I would say, the market trends and the latest momentum happening on the market. First one, it's a classic, and it's coming from the UN Trade and Development, and it's an entity under the UN. So it's, as you all see, that the investments and the market share and the business of the AI is going to quadruple by 2033. So we have like at least of 8 years of I would say promising opportunities on the AI domain. And while we were preparing for this webinar, that was a recent, I would say, press release that we all saw, the partnership between NVIDIA and Nokia. And for us people working on the telco, that's really a remarkable thing. So it seemed that there are a lot of now of intersection or convergence happening between NVIDIA and all the other players. And even Hamada, we tried to bring something more holistic, and you broke this one. So it looks like, there's a lot of convergence between those big players.
Yeah, so if you look at the arrows in pink, sorry, those are just hardware and software purchases or partnerships between those. But if you look at the ones in baby blue here, so those are investments. So NVIDIA is investing in Intel, NVIDIA is investing in OpenAI, OpenAI is investing in AMD. So it's a huge mesh of investments because everybody sees that, it's going to be much brighter future. Of course, 100%. Lots of those companies will eventually fail and fade. We have seen that happening. But in general, we have seen also that when you bring value, and there is lots of value in AI, so this will continue at a certain stage.
Okay. For me, this makes the whole ecosystem more solid and more less prone for I would say bad things. But on the other side, from investment perspective, does this like possess a risk to the ecosystem?
It definitely will. I mean, so if for example, OpenAI with that huge potential and that huge amount of money pushed into it, and we suddenly found OpenAI with Gemini 3, for example, or Mistral, the new one they come up with, is not relevant anymore. That means lots of money have just evaporated. So, I mean, and this is
Yeah.
where the economists say there might be a bubble happening, but I'm not an economist, so I don't want to talk
Yeah,
about that.
yeah. Me as well. For me, I don't believe it's a bubble. I think it is a technology. It is here to stay for a long time. We are working, for example, in 6G on making that part of the anatomy of the network. So let's see. One thing also is very, I'd say, trendy and very relevant to technology, which is the adoption of the technology on the nation's level or in the country's level. So we saw now like national initiatives in the UAE. Like the G42 and in Saudi Arabia, like the Humane. And lately we saw this, like US approves the latest, I mean the export of the latest NVIDIA chips to both countries. So it's yeah, it's everywhere, right? I mean it's
Sovereign AI is a big word right now. So every country is trying to build their own sovereign AI because
okay.
it's more of a, I don't know, it's an asset now.
Yeah. So as you all see, it's not just like an enterprise or a company trying to break through. It's like more into a worldwide initiatives happening everywhere. And for us, the skill set, I mean, career-wise, uh, it's not a secret. Like, and I brought here like one survey from the World Economic Forum this year, talking about that the jobs of AI and big data are on the first rank. So this is are the most I would say demanded skill set. And that would bring a topic, okay? Like for me, I'm a person coming from a telco background. I know Hamada, you're coming from also from a network background. So, uh, like, do we all have to be data scientists? Do we need to be like what ML ops
Yeah.
or
Well, that's the thing. I mean, so this is what me and Karim try to explain during this presentation because I hear a lot of people coming and asking, okay, I want to start on AI. Okay, so this is a big thing. Okay, where do we start on AI? So, but you can just be a user, by the way. At a certain point, if you don't have any of those network or infrastructure or AI, you can be just you need to learn how to do prompt engineering, how to ask the question for AI. So and that's also a thing happening. So there are so many levels of AI which we'll try to demystify during this presentation.
yeah, and that was actually the original idea of the webinar is to define the entry points for everyone to understand these points and then start to think, okay, maybe that's my entry point. Maybe I can roam a little bit from my comfort zone or from technical domain and get into this AI domain or subdomain. So I hope we can do that throughout the presentation. Okay, so we all love stacks, right? Most of our technologies in the teleco, 3GPP, and the network, even on the software, we all look for a stack that explains the different anatomy of the technology. And what was very interesting for us that while we were preparing for this webinar, we got one. We got a really solid one from Jensen Huang during one of the GTC keynotes, actually the latest one, almost 10 million views on YouTube. So he classified the AI stack or the AI domains into energy, GPUs, infrastructure, models, and applications. So we extracted the same stack because, I mean, me personally, I always try to provide some sort of a vendor agnostic content, a content that can be embraced by the community. And when it's coming from NVIDIA, so that's a remarkable thing. And most probably many I would say technology suppliers will follow even the same structure. So we broke the stack and we thought about what are the entry points. Like we don't want to get overwhelmed by the technology, but since we have a stack, so we will have some entry points at each layer that maybe looks like the foundation of each layer. So if you want to start learning or understanding the AI or getting into a specific domain, these entry points would help you. So from application perspective, before we talk about a use case or an application, one needs to understand the market segmentation, like how we suppliers and how the technology partners or firms define this market segmentation from AI maturity perspective, from digitalization state, and how this actually impacts the use case. And the models, we all hear buzzwords, right? Like LLMs, training, what about
Inferencing,
RAG,
Llama.
Llama. Yeah, right. So you need to get to be like able to identify the main or the core characteristics of a model. You need to understand the consumption model, like how an enterprise can start to work on this model or make use of this model. Is it like a SaaS model, or you download it and then it works? And also, when we talk about the lifecycle management, this kind of stages that construct the life cycle of a model, starting from the beginning, like defining the use case, right? Training, fine tuning, as I said, and then model serving or to how to inference the model. So you need to understand this kind of life cycle aspects, and then right, the GPUs and the infrastructure. So we all, I think, most of us, worked before in data centers infrastructure. Me, I did as well, and Hamada for sure. So how this new infrastructure is different, right?
Yeah.
I think Hamada, you talk about that.
Yeah, and it is much different.
It is much different. And then the new terms. I mean, what is MLOps platform, and what are this kind of platforms? Are they like close to the platforms that we are using now, like Kubernetes, or they're different? And then why there's a buzz about the energy? Why there's a lot of talks about the energy? In the latest keynote, the GTAC, Jensen Huang, he thanked Trump, right, for availing the energy for NVIDIA. So it's a major thing. And that's how actually we structured the webinar. So the next section, which are the code sections, we are going to go through these domains, try to cover like the main questions, and give you the chance after the webinar, if you want to get more details. We hope that with this kind of content, it will be easy for you. I can stop here, and if there are any questions, please feel free to use the chat or the Q&A, and I will take it from there. Otherwise, we can just go quickly and go to catch the, I would say we have 1 hour, so we go to the AI applications. Okay, so you can just like shoot your question in the chat window at any time, and we will take it after each section. Okay, the first part, we will start from the top of the stack, which is the AI applications, or the as we wrote it here, the quest for use case. So we are in 2025, right? So we are not in the 5 years back. So we have a level of maturity now that allow us to say that yes, most of the enterprises are using AI. And what was interesting from this McKinsey report that was issued this year, that 78% of the survey attendees for the enterprise firms are using AI for a certain business case. And as you see here in the graph, starting from the 2023, which is the year of AI booming, the use of generative AI has spiked or boomed, so that now around 71% of the enterprises are using Gen AI. And from a use cases perspective, when you talk about Gen AI and the enterprise use, I think Hamada, maybe internally in Cisco and even in Red Hat, we use our own ChatGPT model, right? So this is our use case that we use for Gen AI, right?
Yes, internally. So there's this, but also there is external. So what we give to the customer with features when it comes to AI.
Yeah. So if you see, I mean, the knowledge management is part of the Gen AI use cases, but it seemed that the marketing and sales, that any kind of customer facing solutions, like this kind of
Well,
things.
that's revenue generation. So
Yes,
definitely that would be the focus.
exactly. So you'll find Gen AI very, I would say, closely coupled with the marketing and sales domain. Currently, we are trying, for example, in Red Hat, as part of our portfolio, is to help you generate Ansible playbooks using Gen AI. So you can just start to express your requirements in a very declarative way, and then we generate the playbook for you. So Gen AI also is coming in the automation and orchestration field. Would you like to take this one, Hamid?
Yeah, wow. We need actually to think how enterprises formulate their use cases, right? And why is this important? Because first of all, you need to identify, because we're all here either owning our companies or working in companies or selling to companies. And we need to understand where are we. So this is where the market segmentation comes in handy, okay? Because, based on where you are, you will have different type of adoption of AI. So, for example, there is the technology centric segments where those are the digital leaders, for example. Those guys invest a lot in technology, they try a lot, they drive the business model based on technology. I mean, Netflix is an excellent example. Why? Because I mean, Netflix is not a technology company, right? You would think so, okay? Netflix actually is a video rental company that was competing with Blockbuster, who was just renting videotapes, okay? But the value of Netflix that it moved itself from this to a technology company. So using their AI, so they have built their whole ecosystem, their whole management structure on technology. This is where AI now, or that's actually machine learning. When you open a Netflix video or movie, they learn what you like and propose new things to do for you. Sorry. Okay, so that's one type of a market segment. The other one is the technology enabled. So or maybe you can say it late adopters or whatever you can name it. So those are very big companies. Maybe your local bank, your huge retail that is around you. Those ones are well established. They only go, so they did not build their ecosystem over technology, but they use technology a lot. Okay, and they focus on the measurable return of investment to adopt a certain technology. Take example Disney, for example. So Disney is a movie company compared to Netflix, which is a technology company. Now they are trying to be more towards technology. Okay, so they're trying to adopt more and more like this. The final one is the technology assisted, and those are the beginners and the small ones. Those one basically just go and buy their own, that ready-made stack. So compared to the technology enabled, so the technology enabled take somehow a stack, or they might build a stack and tailor it on themselves. Technology assisted, well, they did not do that. They buy ready-made and it's not tailored for them. I think, Karim, you can take how AI
Yeah.
maturity levels now. So after we talk about how we can segment them.
Yeah, exactly, Hamada. And thanks for this nice, I would say, structure of the market. But do you actually like work with that? I mean, and do you position different strategies for each segment?
Personally, when I talk with, so mostly I personally talk with technology assisted and technology enabled.
Okay.
When I go to technology assisted, I try to talk with them about RAG, which we'll learn what RAG is.
Okay.
But technology enabled, no, we have to think about use cases. We need to talk with the business people there to come up with a use case.
Okay. So this is how I see it actually. I mean, and when I look to the market, I tend to classify it into three segments: the adopters, starters, and watchers. So the adopters are the ones who have already, doing AI since a while and starting to even to have an operational AI solution. So they manage the full lifecycle management. And with those, I would say, market players, they usually ask for clear, let's say, requirements or actually clear products. They're looking for complete the MLOps, I would say, scene. Usually they have solid DevSecOps process, so they somehow converge both DevSecOps and MLOps. And actually, from use case perspective, they started to have some sort of an intelligent app factory. So they have a solid process that allow them to get the business requirements and filter these requirements, verify this requirement, and then have these requirements passed into a very strong and robust pipeline that would eventually bring the intelligent app or the use case. The starters, those are the ones, and we see that I would say in the region in the Middle East, that, and I speak about telco. I work with telcos. So starters are those telcos who have a budget, and they are in the process of piloting projects. And for those players or those I would say enterprises, they require quick wins. Okay, so get us some quick wins so that we can catch up with the competition. And for that, Hamada, we usually position some sort of consultancy services. And these consultancy services help them to stimulate the business case. So we help them to get business case. And then once we get the business case, we turn that into a pilot and show that to the executives. Everything's fine. Your budget now is in safe hands. Let's streamline the intelligent app delivery. Watchers for me are, those are the players who are somehow still reluctant. They have some uncertainty. And usually with the watchers, we don't deal with the design teams or the AI teams because maybe that AI team doesn't exist. But we work with strategy, with R&Ds, and the ask here is always a POC. Once you do a POC, you try to support them as much as you can to, find a budget, to get a budget, because what would eventually move you forward. So these are the market segments and how they come up and stimulate the use cases. We go to, I would say, an interesting part in our webinar, and which is actually going down from the stack. We talked about the application. Now let's talk about the machine learning models, or what I called the AI engine. So instead of starting with a classic, presentation or slides about what is ML model, and which I suppose that we all know to a certain extent, I try to find the entry points. What do you need to know about the ML model so that you can build a specific perspective? So I classified the characteristics of ML models into different sections or different groups. One of them is the core specifications. Okay, what are the core specifications of the machine learning model? So we bring here like four main, I would say, aspects, which is classically the model name. Okay, and the developer who did that, like Llama, like Granite, like Meta, IBM, the developer. This size, the parameter count, and usually whenever you interpret the model name, you find a number like 7B, 30B, or whatever be it, and these are the billion, 7 billion parameters. And the parameters, it's a reference to the model knowledge. So you may assume that the more you get parameters, the more the LLM have knowledge. And actually, this is one of the parameters. When you start to call a machine learning model a large one, it's actually one of the aspects is the parameter size. And parameter at the end, it's a group of weights, bytes that actually express the knowledge of the machine learning model. And the architecture type is actually the underhood technique that the model is using to interpret the prompt, the inputs, the tokens. And there are different architectures that you may find within in that domain. You get names like transformer, you get like Mamba. So you need to understand what high level what these architectures are actually doing. And then the modality, okay, do these models behave like humans? For example, I'm a multimodal. I can interpret text, I can see visuals, I can hear sounds, I can smell. So I'm a multimodal by myself. I think, Hamada, you're a multimodal?
No.
No? Okay. Okay. And the others are unimodal, like interpreting specific kind, maybe text only. So I brought here an example just to visualize or just to show you these aspects. For example, the model is Llama 3, that's the name, 70B. So now you know that it's 70 billion parameters, and it is developed by Meta. The size is 70 billion parameters total, so that's the second aspect. And this model is working by decoder-only transformer architecture. And this architecture has its own characteristics, and you can compare that to maybe to Mamba, and each one has its own requirements in the inference time, its own technique of interpreting the tokens. So that's the architecture type, and the modality, that's a text input, or that's a text only. So that's a unimodal unimodal machine learning model. The other group of aspects, which is not very famous, I think, which is the usage and the consumption model. How enterprises use and consume the model? What is the licensing model of this machine learning model? Is it like a vendor specific? Is it GPL? Is it Apache 2.0 open source? So you need to understand that, because based on that, it determines many things. For example, if I give you the model and then you take the model and you do a proprietary solution, are you allowed to do that? Maybe under Apache, yes, but under GPL, no, you're not allowed. So this is a thing that you need to understand as a professional. Deployment method, are you going to consume that using API while having the model somewhere at the Hugging Face on a public cloud, or it can be deployed on-prem? And then eventually, and we all talk about that, the hardware requirement, what are the GPU and the VRAM requirements? I brought an example here. For example, Granite. And I choose one of the families of the Granite, which is Granite 4.0 small. It is developed by IBM, but it's now open source since I think since maybe more than 1 year. And it is open source under Apache 2.0. What does this mean? That if you get this base model, okay, you can just take it, tune it, you can come up with your own products and start even to license them. There is nothing mandating here because of the Apache 2.0 that you keep on the source code and you make sure that this source code is available for the community. No, this is not the Apache. Okay, and it is flexible. For example, in one of Red Hat solutions, and I hope we will have time to talk about our own solutions in next webinars, you can simply deploy the base model. Red Hat provides you with the tools with Rel AI to do similar to the RAG. We have something called Instruct Lab tools. And then based on that, you come up with your own GenAI case or GenAI deployment. So there's a flexible deployment method. And from the hardware requirements, for example, you know now that if you want to have inference or you want to do inference of this model, that's a recommendation from NVIDIA. So you have the L40S with 40 gigabyte VRAM. Okay. While, for example, Granite is well known of having this kind of efficient efficient deployment that require less RAM, where you do like some sort of a compact deployment going from 32 byte model billion to 9 billion, and that would eventually allow you to get this done in a 33 gigabyte VRAM. So when you interpret the characteristics of ML model, these parameters are important, okay, to understand I would say the identifier or the metadata or the characteristics of the model. I end with this one, and it is important, at least the second one for me, that there is an important aspect, which is the context window size. And I think you have all witnessed that in ChatGPT and the tool that you are using, that when you start to provide more content and more text and the history goes wide, sometimes the tool or the ML model starts to do some sort of hallucination because he has some sort of a limited context size. So the context window, okay, that what allows the LLM to understand the conversation history, instructions, and this kind of thing. The indemnification, it is very important. You need the ML provider to protect you, right? Because if you give you a foundation model, and then you find that this foundation model was trained on, for example, some private data sets, and then you use this model, maybe you'll be subject to to any kind of risks, right? It may take you to court. So indemnification here means that the supplier, and we do that by the way in IBM and Red Hat. So when we give you the base model, we offer the indemnification. So we support you, we legally support you. So that, for example, any problem during the training of the foundation model, any problem about, for example, the intellectual property or patent, issues with the ML model itself, we protect you with that. So those were like the main characteristics of the ML model. If the ML model has a business card, these are the entry point. Those will be the entry points for you. I see there is one question, and then Hamada, I will take you this one. Yes, we got a comment about that modality is not a core specs nowadays, and all the models are multimodal. Yes, exactly. So most of the models are turning into a multimodal, just make it more diverse. And then we got a comment from Mohamed Hanafi. Thanks, Mohammed, for that. You need to add the context lens or the sequence window, and it came here, but maybe we can add it like to the core aspects.
Yeah.
Right. But yeah, 100% we agree with you. And then a question about if the models is a live thing, so we get one every day, so it gets like enhanced releases, this kind of thing.
Yeah, there is a well, the model itself is not a live thing, right? Well, though it takes feedback from the inference. Okay, so it uses the inference to learn a little bit more and continue. But the model itself, so for example, versions of models, no, this is not a live thing. So that does not go every day. So we just saw yesterday, I think, or maybe the day before yesterday, Gemini 3.0. Okay, before that, maybe like 6 months ago, it was Gemini 2.5. So no, that's not a daily update.
Yeah, I agree with you. So if it's that easy to to go with a base model or the foundation model, so why people complain, right?
Yeah. Okay. So basically now the question is, okay, now models are there, it's easy to use, okay, but the problem is there is what we call like the deep internet, okay, and the deep network or and the regular internet. So and the deep network have the most of the data. Okay, now if you go and ask Gemini, okay, how many days of vacation do I have left? It does not know because this information is embedded into your company's data, which is a part of your deep internet. And this is where you need to think, okay, I mean, how would I apply the AI on this thing? Okay,
Yeah.
because I need that on my internal data. So there are several ways to do that. Okay. Now, if you are the Netflix of this world and you have all the data scientists and all those things, okay, and you have all the money in the world, then build your own. Okay, now you collect the data, clean it, do labeling, train a model, create a model.
Yeah, find the right algorithm that you're going to use and then
Yes.
train it. Yeah, so
Yeah. So it's a huge undertaking, but also it takes very long time. And just for your information, I think the first Meta models, the first Llama model Meta produced, uh, only for training, okay, not data collection, not all those things, only the training. They left the GPUs running for around 2 months to get an input for there.
okay.
Okay, so that's excluding all the time needed for the preparation. Now you can say, okay, I'm not that kind of guy, so I'm a more of a big company and I have some data scientists and I can use a model that is there already. So all I just need to do is take the data, clean the data, and improve the output with the help of our data scientists. Okay. Well, the problem is that takes between 4 to 10 weeks to happen at least. Okay.
Hamada, I'd like to reflect on this one because this is the most common, as I was saying, flow,
Yes.
right? That you take a base model, you get access to a base model, and to inject your domain knowledge, you have to do this kind of fine tuning.
Yes.
And for example, in my case with Red Hat, for instance, with the Rel AI, so we provide the tools, which are the Instruct Lab tools, that allow even the personas, like the non-data scientist ones, where they can inject the domain knowledge with a very, I would say, easy way, not necessarily having, the data scientist knowledge. You can try to embed the domain knowledge. So this part, which is the fine tuning, it has really a lot of multiple ways. Many companies different multiple ways. So that how can I inject my domain knowledge in the least time possible? But I would say this is the most common thing that's in the market now.
Yeah, I would say also this is the most common way of using it. The last one is just consuming the models from somewhere else. Okay, I might connect it to my data or not. Okay, that's a different story. But what I think, my reflection is this will be the most common used model in the future. Why? Because now, if you ask me what is AI data, sorry, software that is out there, you probably can name very few. Gemini, you can name quite a few. Okay. But in the future, you will find, you know, for example, CRMs with AI, you will find accounting tools with AI. So that would mostly, I would say that this is what's going to be the main focus in the next maybe 10 years.
But it looks to me as if you are like procuring the product in the same old way, but it's an AI product.
Yes.
Is it like that you go for a holistic solution, right?
Yeah.
You don't have to, I don't know.
I think it would be like I think this is how it's going to be. I think it's going to connect your data much easier. Um, Yeah, I'm
Okay.
quite sure that is how, because you have to think about the financials at the end,
Okay.
right? So how many companies can do the two ones above, and how many companies can do the
Yeah.
one below?
Yeah, this is the point. I mean, from Red Hat perspective, for example, we try to make the green easier. So
Yeah.
that's our strategy. We're trying to give you a quick path to do the green one easier so that you can, maybe start second path. But I agree with you, this is like a quick win or the most, I would say, brightest
Yeah.
path. Okay, so we have 20 minutes and we have now the core part, right?
Yes.
The one that you love, the GPUs, right? We have a lot of buzz stuff about GPUs. So Hamada, why don't you maybe start take this one?
Yeah, sure. So what is the infrastructure landscape look like? Okay. So we again we are engineers. We've been raised on OSI models, so we try always to come up with our models. So it's quite different. And today we're only going to focus on two. Well, I mean, every one of those even can take days, even folk, I mean, in discussions, but I'll try to quickly touch on those two. But let's go through the whole stack quickly. Okay. The network fabric of AI is different. Okay. The the core infrastructure, so the compute part is different because before it was CPU, now it's GPU. Okay, that does not mean that there is no CPU at all. There will be CPU, and if you have that very expensive network and GPUs, you need to work on it, smartly. So automation of those components would come very handy here. Um, Also the cloud platform, but that I'll leave to Karim, of course.
It's classic, right? You need to produce applications, right? So where do applications live? They live in cloud platforms. They live on solutions like VMware, OpenStack, Kubernetes like. So you still need to have this kind of foundation to host the AI workloads. But on top of that, the AI framework and tooling, this is, I would say, the solution that we do have now in the market, that these platforms are starting to provide an MLOps platform that give you the tools to manage the lifecycle management of the model, what you see on the top. So you get the tools to help you train the model, to help you optimize the model with different techniques, and then you get the tools to do the inferencing. I hope we'll have like more webinars to talk about, for example, Red Hat solution, but we cover at least these two layers with the full lifecycle management of the
Yeah.
model.
And few things remaining here is, what are you going to do with AI? And this is a very important question. Okay. Are you a user of AI? Then yeah, you're more of an inferencing model. You're going to use an inferencing model. And for inferencing model, the infrastructure is different than the ones with RAG. And what is RAG for those who does not know it? So it's a retrieval augmented generation. So basically, it's taking your model, and your model will take a look on the database that you have, okay, search it in a natural language, and come up with an output. Okay, so in this one, it understands the context of your data. Some people say about name it RAG, some people name it talk to my data. There are never lots of names, but it stays the same. And it's part again of optimizing your model and fine-tuning it. Okay, and the last one is building your own model, and that's a very expensive thing to do. Okay. One thing else I want to touch on is that security is quite a key here. Okay. And it's quite different because, for example, a regular firewall would not help you with attacks on an LLM. The attacks on LLM are different. So, for example, what we have prompt injection. So, if you today go ask Gemini, teach me how to make a bomb, okay, it will tell you, no, I cannot tell you that. Okay, but there are ways to play around that. There are prompt injection techniques to get more information, bad information here. But let's proceed and talk about the GPUs now. Okay, so with the GPUs, it's quite different than the CPUs. How is that? So a CPU, for example, you have much fewer cores. And while the GPU have, thousands of lightweight cores. So the CPU basically excels on tasks that are executed one after the other. Okay, while the GPU is good for parallelism. Let's take an example. Okay, now you see the picture on the right here. It seems to be a screen, and there are, lots of pixels. How are those pixels calculated? It's basically, let's say it's at the end at the CPU or GPU level. It's just a calculation. Okay, so it's a number multiplied by a number to generate the color for this pixel. Okay, now if you have 1,000 pixel by 1,000 pixels, how would you do that with the CPU only? So you are going to multiply on the first core, the first pixel with the number, the second pixel in the second core, and so on. And after you finish those four, or maybe on Sapphire Rapids, the latest generation of Intel, 96 cores. So you do simultaneous 96 calculations at a time. Okay, those are very simple calculations, and the GPU and the CPU architecture is quite complex. Okay, it can do much more than that, but I'm burdening it with a very simple instruction. So basically, it will do this over lots and lots of batches. On the other hand, the GPU have thousands of cores, okay, or 1,000 cores in this stage here.
Yeah.
Okay, and basically what I can do is at one batch, because it's a simple operation, I can do this matrix multiplication on one batch on a GPU. So that's the main difference between the GPU and the CPU, and why the GPU is excelling, for example, for graphics and for AI, because in AI, there is lots of those type of multiplications happening to calculate the weights, which because it's all relations between words. Okay. Now, if I look at the GPUs, for example, and the GPUs manufacturers, okay, so it's not only NVIDIA. So there is AMD, and the one you see on the left here is AMD, which is the MI 300X, and the rest is NVIDIA, of course. What I want to show here is basically the number of cores, for example. So a GPU of H100, for example, would have around 18K GPUs. Sorry, 18K cores. Okay, and compared to the most advanced Intel one, which has 96 cores. If you talk about Intel AMD CPUs, I think they have now I think a bit more than 144 cores. I don't remember the exact number, but the number of cores are quite different. And if I go further into this comparison, okay, so you'll see that it's quite different from architecture perspective. So thousands of cores versus few number of cores. This is the main focus is data parallelism. The other one is sequential flow control. The GPU have dedicated high bandwidth V memory, while the CPU accesses the regular memory. And the manufacturers, NVIDIA, AMD, when it comes to GPU, and Intel, AMD, when it comes to CPU. There are also some other non-big manufacturers here, like maybe Google, for example, which creates their own, well, it's not a GPU, it's more of a what they call TPU, tensor.
Yeah, but you know what we forgot here? The pricing.
Yeah.
GPU is expensive, right?
It's way more expensive.
Yeah,
Way
okay.
more expensive than a regular CPU. Yeah.
That would be a perfect comparison if we put the like some benchmarking on the prices.
Yeah. Definitely it is. We should have done that.
Yeah.
Now, if I go, and for the sake of time, we have to move a little bit quicker here, but if we try to understand what the AI fabric would look like, okay? So we talked about the GPU part, okay? So that's what we call the back end. And there is the front end, whereas we can call it the inference or the connection to the outside world. So depending on your model. And then there is the storage network and their management network. Okay, so that's from network perspective. But also each one of those, okay, would have more details to talk on. Like for example, the training network needs lots and lots of GPU. Okay, and from the network perspective, it needs very, very high bandwidth. Okay, would your regular Ethernet work in an inter-GPU back-end network? Well, it will work, okay, but it will cost you a lot. Why? Because we talked about Llama, and it took 2 months of training, that one. Now, if there is, I'm not sure if I remember the numbers correctly, so we might return on that. But if we had 0.01% packet drops in that network, actually the training time would have doubled. So instead of 2 months, it would be 4 months. So that's how important this network is of the training of the back end. Okay, so the infrastructure requirements are quite different. When we talk about the inference, for example, okay, what we care about is not the very high bandwidth. Well, at this stage, at least, it's not the very high bandwidth. When we reach a stage about agentic AI, then yes, bandwidth will be high. But for now, it's just because what you do is, you go to your LLM, ask it a question, so it comes back. So it's not high. But on the other hand, the latency should be very important because a use case, for example, with a factory using the cameras to decide when to stop the manufacturing process, if it finds a hazard, like a mechanical hazard or whatever, people going to the wrong places, the latency has to be very low because actions has to be taken very quickly on that, and maybe self-driving cars and lots of other things like this.
Yeah.
Yeah.
Hamada, seeing you talking about this point, I got like one idea that when someone asks, okay, what is my entry point? I feel it comes organic based on your I would say specific domain. For instance, if you are working on data center infrastructure, maybe your first move is to understand the AI fabric, right? Understand the networking requirements, how to build the network for AI. For me, if I'm working on, for example, OpenShift or Kubernetes, then the MLOps platform that is on top of OpenShift, then it makes sense that I understand it, right? If I am a developer, I'm working with Python. Okay, let's go enter from Python. So it seems like based on your background, you can find the right entry point, right?
Exactly,
This is
exactly. Unless you want to change careers.
yeah, that's fine. That's fine. But at least the entry point now is at least is clear for me. Okay. Well, I'm not sure if you're already bored already, but we are going to talk about the final part, which is the energy. Okay. So Hamada, so I know you had the GPU and infrastructure, so it makes sense that you
Yeah,
talk about the energy,
yeah,
the AI lifeblood. Yeah, you
yeah.
agree?
So why is energy very important? So you see on the right hand side on the green what do they call the green thing?
Green.
So yeah, so that one is how much NVIDIA B200 uses in terms of power. So that's 1000 watts, okay, versus 350 watt of 86 cores. Okay. So now if you think about it, on the left side here, this is how the server, an HGX architecture server. So that's a HGX is NVIDIA term for their validated or what they call. So it's valid, yeah, an NVIDIA term for its big servers. Um, and those ones have 8 GPUs, and I think it's around 7 or 8 rack units. So that 7 or 8 rack units consumes around 13 kilowatts.
Okay.
Okay, versus if you have uh, just 86 cores, and this is the highest one
Yeah.
in Intel right now. Okay, with one rack unit, it takes 1.2 kilowatt. Multiply that by 8. So that's around
Okay.
what? Yeah, that's there is around 30-40% difference.
Okay.
Okay, so there is a huge difference, and now there is a huge bottleneck when it comes to energy, and because this is just one server. Okay, think about the amount of servers you need. For example, XAI, I think it's more like thousands of
Yeah.
servers.
Think about the data center itself. I mean, if this is like the delta in between group of servers, so what about the racks? What about data center?
Yeah, it's definitely huge
Yeah.
difference, and this is why this is wattage is the new currency. And if you see here, for example, this is a general piece of news. It's just probably like 2 days ago, and I just wanted to point out, okay, that the way they talked about it, they want to build 1 gigawatt of AI infrastructure. So they don't say, well, 10,000 GPUs. They don't say hundreds of servers.
Mm.
No, they don't say it like this. They say 1 gigawatt of AI infrastructure because AI infrastructure is becoming the bottleneck. We heard about Facebook buying or trying to build a nuclear
Nuclear.
plant.
Yeah.
Yeah, so that's a big thing just to power their AI infrastructure. And by the way, this actually will do so once this hits the limit, so there will be shifts on how the AI is going to be implemented. Because now, as we speak, the AI is mostly on the data center, but most of the data centers would not be able to cope with that power. So it might be needed to be distributed. We go to the edge more
Yeah.
with more GPUs around the edge.
Yeah.
I think we're on top of the hour,
Yeah.
so
Actually, yeah, we did it.
yeah.
So let's have like a quick like let's wrap up. Well, when we thought about doing this webinar, we wanted to make it like a starting point for the professionals, network professionals who are trying to understand the entry points to the AI. So we got this nice stack from NVIDIA. So why don't we use this stack in, I would say, defining some sort of a career path or a career moves and see where the one fits in and then start to rule. And my personal experience, what I did is that we started, for example, from the platform. I claim I have good knowledge about the Kubernetes and OpenShift, and then when that started to evolve to an MLOps platform, I took that step. I started to learn about the tools that we use. I started to learn about the lifecycle management of the machine learning model and how this platform offer this kind of lifecycle management services to the ML. Uh, I try always to understand, the sufficient, I would say, information about the different layers. And what is important for me, for example, at this time, at this career stage of my career, is to understand the end-to-end picture. So we tried to reflect that in the webinar. I'm not sure, did we succeed to do that? Or?
Wow. I understood myself, so I don't know about the people here.
Okay.
So yeah, and from my side, I just want to talk about two things. Okay. So the first one is because I got asked a lot, okay, I mean, I want to start an AI. How would I do that? Okay. And um I think the best way is to find your sweet spot because king of everything is king of nothing, right? So don't say that you're going to start to learn all the way from being a data scientist to a developer, then to infrastructure manager, then to a network engineer, with ML ops, with security. Nobody knows everything. Okay. Focus, find your sweet spot, your area of interest, and go for it. That's number one. Number two, do not approach your AI workload as your traditional workloads. The network requirements are different, the infrastructure requirements are different, the server requirements are different, security requirements are different. So everything is different. Do not try to use what you learned totally and copy it into AI. Most probably it wouldn't work.
Yeah, I agree, Hamada, with you. It seems that we have like a very common point of view about many things. Yeah,
Yeah.
I didn't know that before the webinar, but yeah, it turned out to be true. Okay, we would like to really to thank you for being here with us. If you have any questions, please feel free to post it. We will take that offline, and the recording of the session will be available on YouTube and on LinkedIn. We hope to have more episodes of this webinar. Maybe we can zoom on
Yeah.
these layers and show more information, more content. Thank you all, and see you next month. Bye bye.